Welcome back, fellow professional computer touchers. I'm wearing an overly sized shirt. I'm still dunking on these problems. This is 88 merge sorted array. This problem isn't too bad, but it can be a little confusing. I'm not going to lie, right? First time I did this, I kind of struggled with this, but now I kind of really get it. So I'm going to explain it, hopefully give you a solution that's intuitive. This is not the best possible solution you can do this with, but I think there's real value in starting with a trash solution, right? Then you can iteratively make it better, right? By layering your own understanding on top of it, then you can create a better solution. Overall, you retain it better and you actually understand it better. So I think there's real value in starting with a trash solution. But let's get started. Given two sorted integer arrays, nums1 and nums2, merge nums2 into nums1. The number of elements initialized in nums1 and nums2 are m and n respectively. You may assume that nums1 has a size equal to m plus n such that it has enough space to hold additional elements from nums2. So what do they mean by this, right? So we're getting 4 inputs into this function, right? Which is a little bit confusing at first because we're supposed to be merging these arrays, right? But it says modify nums1 in place instead. So we're not returning anything, right? So ideally we're modifying this, right? This reference right here. When you come out of the function, it's still going to be modified, right? But it's a little bit confusing, right? And so how do we demystify it a little bit, right? So the actual length of the array, right, in this example here, is 6. There's 6 elements in the array. What they're giving us is m, which is the length of the elements in the array that are in use. So the last in use element. So that's going to be 3. 0, 1, 2, right? And when you loop through, right, 3 is exclusive, so it's really only 0, 1, 2. So you have 3 elements in use. So the actual number of elements in the array, right, if you're in Python, it's going to be just the length of the array that's going to give you 6 here. But a more intuitive way, I think, to think about it is you get the actual length of the array, right, by adding m plus n, right? Because the problem says that you may assume that nums1 has a size equal to m plus n. So we know that there's enough space, right? So how do you go about doing this? So it's weird, right? We have to merge nums2 into nums1, right? But nums1 already has items in it, right? And it's already sorted. So it's a little bit it's a little bit tough, right, to do it in place. So how can we simplify it, right? So we can simplify it, right? So imagine, right, if we could copy, nums1 into another spot, right? Let's just call this copy. Right? And we could just do this. We could just copy the in-use elements into this, right? And m here would still be 3. But nums1, right, would still be the same as it is up here on this line. Right? Let me make this a little bit bigger, right? And so what's important, right, is that if we were to copy it, right, now we can still do this in place, but it's a lot simpler now, right? Now we just have to choose between, hey, which one of these elements is smallest? Put it in this spot. Which one of these elements is the smallest? Put it in this spot. Which one of these elements is smallest? Put it in a spot, right? So how do we do this in a way that makes sense? So we're going to have 3. So we've already established one thing we have to do, right? Copy the in-use elements into another array to simplify data or we're going to say simplify index management, right? Because it's complicated, right, to overwrite values, right, it's a little bit complicated to overwrite values, right, as we're merging the elements into the array, right? And so this is actually going to be a little bit simpler to implement. So we copy the in-use elements into another array, right? And then from there we're going to need 3 pointers, right? They're not literally pointers, they're just going to be indices that we're going to be managing, right? So P1 is going to be a read pointer, right? And it's going to be the current element so far in copy, right? And P2, right, is also going to be read. It's going to be the current element so far in nums2. So why do we need these, right? It's because imagine that you want to merge these 2 arrays, right? You're not going to literally be choosing, right, pairwise between these elements all the time, right? I mean, you're always going to be choosing between 2 elements, right? But the indexes are never going to be parallel all the time, right? So in the beginning, you're choosing between 1 and 2. You take 1, right? But after that, this one is going to move to 2, right? And so we need to choose between 2 and 2. So we just choose the first 2, right? So now we're choosing between the second index in nums2 and the third index in copy, right? And so that's why you get this kind of asymmetrical, right, kind of pointers that we're looking at, right? And so that's why you need two separate pointers to read at two different elements, right? And so P2 is just going to say how far along are we, right, in adding each element and merging these elements into the list, right? And ideally, once both of these reach M and N, right, there's no elements left to copy, right? And then we're going to have P3 where we're actually going to change it to right? And so this is going to be the index that we are overwriting in the original array, right? So we need to do this in place, so we have to modify. We don't have to do this in place. We have to modify nums1 in place, right? And so the right is just going to be what we use to iteratively write to each index in nums1, right? So we're going to iterate, right, while P1 is less than M and P2 is less than N, right? Why are we doing it this way? So the goal here, right, is to make sure that we can exhaust one of these lists, right? Because this is going to run, right, while P1 is less than M and P2 is less than N. So if we ever stop, right, it's because one of these values, one of these conditions has been broken. And for one of them to be broken, it means that one of them has reached the end, right? So once we get outside of while loop, we have exhausted one of the lists, right? So if this is going to be a given every time, right? If we get out of this while loop, we've exhausted one of the lists, right? But the thing is, if we've exhausted one of the lists, right? In this case, let's humor me and we'll do this real quick, right? So 1 or 2, right? We're going to choose 1, right? And we'll just kind of run through it, right? Kind of as though we were doing this, as though the algorithm was working here. And it's important to do this, right? Because we have to read through the code and work through it line by line to see what we're actually writing. So both of these start at 0, and M is equal to 3, N is equal to 3. So they're both starting at 0, right? So we're choosing between the 0th index in both of these lists. I'm just going to swap these so it's a little bit more intuitive. So we're choosing between 1 and 2, right? We're going to put 1 in this index, right? And I'm going to create right is equal to 0, right? So we're writing at the 0th index, and we're checking between these two indexes, 0 and 0. Which one's smaller? 1, right? So the first list, we're going to take 1 from the first list, so we're going to increment 1, right? And now, right, we're going to go and increment right. Now we're looking at the second index in the list, right? Which one's smaller? The first index of the first list, right, which is 2, or the 1th index of the first list, which is 2, or the 0th index of the second list, which is 2. Doesn't matter, right? So we're just choosing arbitrary one. We're just going to say that we're just choosing the first list again. So we're going to increment that, and then 2 gets put here, right? And then now we're looking at the second index of this list, with 0, 1, 2 is technically the third index, right? So which one's smaller? The second index, or the second index, which is really the third index in the first array, or the 0th element in this array, in the second array, right? It's going to be 2. So we're going to change this to 2, right? We're going to increment P2 to 1 and right to 3, right? And so now we're almost finished, right, with both of these arrays, right? We're at the third index, which is this one right here, which is the 0. Which one's smaller? Item at the second index of the first list, which is the last element, or 5, right? 3 is the answer there, so we put 3 here, right? But boom, right? If we look at this while loop, right, now while P is less than M, that condition is broken, right? Which means one of these lists is exhausted, right? Which is the first list. So now what's left, right, is we're at the 1th index of the second list, which is nums2, and we still have 2 elements remaining with 2 slots available, right? So now, right, we have to say, hey, if P1 is less than M, right, which means we didn't exhaust this list, right, funnel remaining elements into nums1, right? Now, if P2 is less than M, we didn't exhaust this list, right? Which is precisely what happened in this example, right? P1, right, is not less than 3, right? So this is not going to run, but P2 is, oops, I said M. Is P2 less than N? P2 is 1, and it's less than 3, and there are 2 elements remaining and 2 elements available in the list, right? So now we have to funnel remaining elements into nums1, right? After that, right, this algorithm is done. So it's very similar to merging elements in a linked list. If any of you have done that problem, but basically, right, we're going to iterate while P1 is less than M and P2 is less than N, right? Choose the smallest value. So we're going to say if nums sub1 sub copy, right? And this is, we're just all doing pseudocode here, right? So we're just going to call this copy, right? Sub P1 is less than nums2, right? Sub P2, right? We're using P1 and P2 because P1 is a read for the current element in copy so far, and P2 is the read for the current element in nums2 so far, right? That means that if this passes, right, that the element in P1 is the smallest element. If that's so, then we're going to write it to nums1. So nums1, right, sub right, we said right is going to be index that we're overriding in the original array. It's going to be equal to copy sub P1. Then we're going to increment P1 just like we did when we were going through the example, right? If we ever choose the smallest element and it's the element we chose, we're going to increment it, right? Else, we're just going to mimic exactly what happened, right? If this is not true, right, it means that nums2 is less than it, right? So we're just going to do the same thing. We're going to write nums1 sub right is going to be equal to nums2 sub P2, right? And then we're going to increment P2 instead. And at the end, right, we're just going to also increment right? And so right is going to be done in a while loop, right? And so we're going to have to increment right to make sure that we're slowly iterating through the array, which is nums1 that we want to overwrite the values for. Whew. That was a mouthful. All right, so now we can implement it, right? So we said, first thing we have to do is copy the in-use elements into another array to simplify index management. So let's just call this copy. We're just going to call it an array, right? And we're going to say, hey, iterate for index. Actually, we can just do, we'll do for index in range of M, right? And we said M, right, was the last in-use index, or last index of the element that is available, or the first index of the element that is available, but also the length of the in-use elements, right? Because there's 3 elements in use, and M is equal to 3. So we're going to copy the first 3 elements, basically, right? So we're going to iterate through the loop with an exclusive end, which is going to be 0, 1, 2. Say copy dot append, right? Nums1 sub index, right? And thus, we've copied the array. Now we're going to need 3 pointers, right? P1 is going to equal to 0, P2 is going to equal to 0, and right is going to equal to 0 as well, right? And now we're just going to loop through, right, P1, using P1 and P2, right, to try and exhaust one of the lists, right? So we're going to try and exhaust one of the lists. We're going to say, well, P1 is less than M, and P2 is less than N, right? Now we're going to choose the smallest value, right? So if copy sub P1 is less than nums2 sub P2, right, that means that copy sub P1 is the smallest element. So now we can just write copy P1 and just overwrite the right index with the element that we said was smaller than the element in nums2 sub P2. So we have to make sure to increment P1 here, and we'll do the same here for P2. And I wrote the scaffolding code, or the pseudocode first, right, so we can understand what's actually happening. And then what you can do is you can just create a logical sequence of propositions, right? And that's how you can solve this without coding. So you don't actually have to code to solve the problems first. You can just kind of think through it. And then it should be like, remedial to write the answer. So we're going to increment P2, right? We have to make sure to increment right, so that we're slowly moving towards the end. If we get out of here, right, we know. And so also you don't have to worry about right going out of bounds, right? Why is that? Right? Because both M and M, right, there's enough space in nums1, right, to accommodate M plus M, M plus N, which means the furthest we can ever go outside in these, or the furthest we can ever go in this array, right, it's going to be M plus N, which is inside the bounds of nums1. So we'll never actually have to worry about right going outside of bounds. So once we've exited the while loop, right, it means we've exhausted one of the lists, because these are going to run while P1 is less than its number of elements in its list, and P2 is less than the number of elements in its list. So if we've gotten out of here, we've exhausted one of the lists. So now you have to figure out which list we exhausted, and so we're going to do that. We're going to say if P1 is less than M, it means we never got to the end of M. So funnel the remaining elements into nums1. So let's do that. We can just say for index in range, and we'll start at P1 and we'll go to M, and we'll say, hey, nums1 sub right is going to be equal to it's going to be equal to copy sub P1, right? And then we have to increment right here, right? Because we still have to move to the end of the array. And so we can do the same thing down here. We'll say if P2, oh, this might be really low. Oh no, it's still readable. We'll say if P2 is less than N, right, we'll find the remaining elements, right? So we want to run from P2, right, to N. And then we'll say num sub 1 sub right is equal to copy sub P1, right? Oops. Nope, it's going to be nums2 sub P2, right plus equals 1. And if we run this, it doesn't work. Oh, it's also because my code is not properly indented because we started with comments. Unexpected indent. Oof, what is going on here? Oh no, we were good the first time. Expected an indent nums1 sub right. Seem to be having a strange, give me one. Okay, I fixed the problem. I had to remove a bunch of comments for some reason. I think LeetCode was having like a, LeetCode was having a meltdown or something, or maybe something happened with the cache. I don't know, but I deleted some comments and it just started working. But so the final thing we have to do, right? So we're funneling these remaining elements into nums1. Funneling these remaining elements into nums1, right? For the first list or the second list, right? Whichever one that was still remaining, right? So the final thing we have to do for both of these lists, for these funneling, right? So for each index in P1, right? This is actually going to be index. This is actually going to be index as well. And then this should be good. And so, boom, there you go. This is merge sorted array. So what's the time complexity, right? So we're iterating through both M and M. Even though we exhaust one list here, we have to go through the remaining list in one of these if blocks, right? So the time complexity here is going to be O of M plus N, right? And the space complexity, it's going to be O of M, right? Why? Because we have to copy M elements into a separate array to do the overriding in place, right? And so what we're doing here, we have to create space for this, right? So there's going to be time complexity is going to be O of M plus N. The space complexity is going to be O of M. And so this is 88 merge sorted array.